Hello. So this video is going to cover solving quadratic equations by using the quadratic formula. So then the first thing that we need to know is, first off, what is a quadratic equation? All right, so over here on the left side of the screen, I have a quadratic equation. And essentially, a quadratic equation is an equation that has a squared term in it. So this ax squared here is one of the main things that you should be focusing on. And as soon as you see that little exponent of a 2, hopefully bells are ringing off, hey, this is one of those quadratic equations. Now, there are a few different ways that we can solve a quadratic equation. The most preferred method, in my opinion, is by factoring. And if we can factor it, we should always do that first. But not every equation can be factored. So if it can't be factored, our other options are to use the lovely quadratic formula or by completing the square. So this video is going to focus on using the quadratic formula. So if we look at that quadratic formula down there, right, what a lovely formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Very, very famous formula here. If your teacher does not allow you to have a sheet or anything like that, and you have to memorize this thing, hey, there are all sorts of songs and chants and all sorts of stuff online that you can find that might help you with that. But if we're looking at this formula, I call this a plug and chug problem. Right? A plug and chug problem is when we're given values to plug in, or we're given a formula and we're plugging things into it, so we need to simplify it down and get an answer. So I call the quadratic formula just a plug and chug formula. And looking at the formula, we have b's in the formula, we have a's, and then we also have a c. So the main thing is first, well, hey, where does that a, b, and c come from? So going back up here to the quadratic equation, notice there is an a, b, c in that formula, and those are important. Now a is always in front of the x squared term. So that's always going to be your a. So if I'm looking at the example that I have on the screen right here, right, 2x squared plus 3x minus 5 equals 0. Well, my a is going to be the 2 because the 2 is what's in front of the x squared term. And that's going to be true every time. Look at the x squared term, whatever's in front of it, hey, that's your a. B then is always going to be in front of your x to the first power term. So taking a look at my example here, here's my x to the first power. And in front of that, I have a 3. So b is going to be a 3. And then c is going to be your constant term. So looking over here, I have a 5. Do note that that is a negative 5. Signs do carry, right? The 2 and the 3 over here were positive. No need to write a plus sign in front of it. But because that 5 has a minus in front of it, we do need to tack on that negative along with that 5. So for this particular example, a is 2, b is 3, c is negative 5. Do be aware when it does come to certain examples that you're given, you could possibly be missing one of those terms. Maybe the middle term is not there. And if you do have a situation like that, then that just means, well, you'd have a 0 for that. So let's pretend this was just 2x squared minus 5 equals 0. Well, my b would be a 0 then for that example. So just be aware that that could happen. So moving on then, after we figure out what a, b, and c is, we need to plug into the formula. So we are solving for x. So x is going to equal, starting with our numerator, a negative b. So the negative is part of the formula, and b is a 3 in this example. Plus or minus the square root of b squared, so b is 3, so that's a 3 squared, minus 4 times a, which is a 2 in our problem, times c, which is a negative 5. So that's our numerator. All over 2a. So 2 times a, which for us here is a 2 times a 2. Now, I always recommend starting with what's underneath the radical here. So this is really just one big order of operations problem. So hopefully we do remember our please excuse my dear Aunt Sally, which just tells us the order in which to simplify down an expression. So we almost want to treat that radical as if it were parentheses, and we want to get rid of everything that we have in there. So I'm just going to move over the x equals. I'm going to drop down that -3 for now and the plus or minus sign. We're not messing with that quite yet. We want to simplify what's underneath that radical. So underneath that radical, right, following order of operations, we would have to take care of exponents first. So we would take care of the 3 squared, which gives us a 9. Then moving on to the rest of it that we have there. So the rest of what we have there is actually, we can look at this as a -4 times 2 times -5. All right, so this is all being multiplied together. So -4 times 2 is a -8. And then -8 times -5 is a positive 40. So we're going to say plus 40 right there. You can also look, you could have also dropped down the minus sign and did 4 times 2 is 8, 8 times -5 is -40, and then you would have been left with minus a -40. And we should know double negative rule says that those do cancel out to a plus. So same thing, just 2 different ways to look at it. Continuing on then, so in the denominator, what we would have, we have that 2 times 2, which is a 4. We can go ahead and simplify that. Okay, so I'm just going to move this up here so I don't have much room on the screen here, and I want to keep this going. So I'm going to bring over the x is equal to -3 plus or minus. The only thing I'm going to do here is underneath the square root symbol, we have this 9 plus 40. Well, 9 plus 40 is 49. And we have that over 4. Okay, so at this point here, we need to work on simplifying down our radicals. So we have the square root of 49. We need to take the square root of 49. So sometimes if we're lucky, like we are here, we are left with a perfect square underneath that radical. So remember, a perfect square is when you have the same number multiplied to itself to get something. So looking at 49, well, what times what, or what times itself will give you 49? Well, 49 happens to be 7 times 7. So the square root of 49 is 7. So I'm going to go ahead and break that down next. X is equal to -3 plus or minus 7 over 4. Okay, so the only thing left to do with this problem, we're almost done, is to take care of this plus and minus sign that we have right there. So when it does come to the quadratic equation here, right, that plus or minus is part of the formula. And remember that that comes from taking that square root, because 7 times 7 is 49, but isn't -7 times -7 also 49, right? And we really don't have a way of knowing which one is it. Is it the positive ones? Is it the negative ones? So we actually assume that it's both. So at this point in our problem, what we do is we kind of split this up. We're going to take that -3, and then we're going to say plus 7 over 4. And then we're going to take that -3, and we have minus 7 over 4. And what we're going to do is we're going to simplify each one of those, and we'll have 2 answers here. So going ahead and simplifying here, -3 plus 7 is a 4, and that's over 4. And 4 divided by 4 is a 1 there. So 1 is our first answer here. Simplifying the next one, -3 minus 7 is a -10 over that 4. And we do need to simplify down that fraction. With 10 over 4, we do have a 2 in common. So we can divide out a 2 to be left with a -5/2. So here we have 2 solutions, and that's almost always going to happen when it comes to solving quadratic equations. That little exponent right here, this 2, typically means that you're going to have 2 solutions. Had it been a cubed, then we'd probably be looking for 3, and so on. So that 2 signifies, hey, we could have 2 solutions here, and our 2 solutions for this problem is the 1 and a -5/2. Okay, so let's try working on another example. So here we're given another quadratic equation that we need to plug and chug into the quadratic formula. So first thing, hopefully, that you should be noticing about this equation, that it looks slightly different than the other one, right? So we have this -8x term over there. Now, drawing our attention back to the quadratic equation I have over here on the left side of the screen. Right? A quadratic equation is in the form ax squared plus bx plus c, and it's set equal to 0. Now, when we're plugging and chugging into the quadratic formula, it does need to be in the proper format. Our x squared term has to go first. Our x to the first power term should be next, followed by our constant, and it should all be set equal to 0. If we're given an example where that is not so, that means we need to have a little bit of a rearranging game going on. We need to move some stuff around so that it could be in the proper format. So then if we want to get this into the proper format, we need to move that negative 8x over. So we would have to add that to both sides. So I'm going to say plus 8x plus 8x, giving us, well, I'm going to drop down the x squared term first, then plus that 8x, then plus the 1, so it's in the proper form. And then that's all going to be set equal to 0. Now that it's in the proper form, now we can figure out what is A, what is B, and what is C. Okay, so remember, A is always in front of our squared term. So here's our x squared. Remember, if there's not a number there, it is understood to be a 1. So A is 1 for this one here. B is the coefficient of our x to the first power term. So in front of our x, we have an 8. And C is our constant. We have a 1 there. So A is 1, B is 8, C is 1. So let's plug and chug this into the formula. So we have x equals negative b, our b is 8, plus or minus the square root of b squared, so that means 8 squared, minus 4 times 1 times 1, all over 2a, so 2 times 1. Now let's go ahead and simplify this down. So dropping down the x is equal to, let's also drop down that negative 8 plus or minus the square root of, remember we want to focus on what's underneath the radical first. Underneath the radical, the first thing we have there is 8 squared. So 8 times 8 is 64. So remember, order of operations tells us we need to take care of exponents first. After we take care of the exponent, we have multiplication over here. 4 times 1 times 1. Well, 4 times 1 times 1 is just a 4. So scooch over the minus, and that's a 4 there. And that's all over 2 times 1, which is just a 2. Simplifying further, let's go ahead and take care of that subtraction. So again, I'm going to just move this all over. X is equal to negative 8 plus or minus the square root of, well, 64 minus 4 is 60. And that's all over 2. So we need to work on simplifying our radical there. So over here off to the side, I'm going to pull out the square root of 60 because we need to simplify that. So we need to remember, how do we simplify radicals? Now we can't just plug and chug this into the calculator and get a decimal. That is not what they are looking for here. So when it comes to simplifying radicals, remember we need to use perfect squares. So perfect squares are the 4, 9, 16, 25, 36, 49, and so on, right? 2 times 2 is 4, 3 times 3 is 9. That's how you get those perfect squares. And what you're looking for is which one of those perfect squares can divide into our number here, or how can we take 60 and break it up into a form of one of our factor using a perfect square. So let's see, if we're looking at 60, the first perfect square that we have that's smaller than that is 49. 60 is not 49 times something. 36 would be the next one, but 60 is not 36 times anything. It's not 25 times anything. It's not 16 times anything. It's not 9 times anything. 4 would be the next one, and actually 4 would work here because 4 times 15 is 60. So what we can do, the product rule of radicals says that we can take the square root of 60 and break it up to the square root of 4 times the square root of 15. Take the square root of the one that we can. The square root of 4 is a 2. Drop down the other one. So square root of 60 is 2 square roots of 15. Okay, so that means we have x is equal to -8 plus or minus 2 square roots of 15 over 2. Okay, so here we just have a little bit of simplifying left to do. If we're taking a look at our problem, we have 3 terms in this problem: -8, 2 square roots of 15, and this 2 down here. Now, we do have something in common with all 3 terms. 8, this 8 here, this 2, and this 2, they do all have a 2 in common. So we can simplify out, divide out a factor of 2 from each one. Or if we think back to dividing a polynomial by a monomial, for some people it's a little bit easier to see it that way if they don't notice that there's a common factor of 2 here. And this is what you would do. So dividing a polynomial by a monomial says that you take everything in the numerator and put it over the same denominator. So we have a -8 and put that over a 2. Then we have plus or minus the 2 square roots of 15, and we put that over a 2. So we kind of split these up into 2 different fractions, right? The -8 over the 2, then the 2 square roots of 15 over the 2. And we simplify each one of these. Well, -8 divided by 2 is a -4. Drop down the plus and minus sign, and then here these 2's are going to cancel with each other. Remember, anytime you have the same thing over itself, they're going to cancel. So we can drop down that square root of 15. So depending on your instructor, you may be able to state this as your answer. If not, if they do want it split up into the 2 different ones, then we would just say -4 plus the square root of 15. And then we have -4 minus the square root of 15. So these would be our 2 solutions for this problem here. Okay, so let's work on one more example here. All right, so taking a look at this example, it already is in the proper form, right? We have all 3 of our terms. It's set equal to 0. All right, so let's find what is A, what is B, and what is C. So taking a look at our x squared term, we have a 2 in front, a positive 2, so A is 2. Taking a look at our taking a look at our x to the first power term, we have a -4 in front, so B is -4. And our constant here is a positive 5, so C is 5 there. So let's plug and chug. X is equal to -b, so that's -4, plus or minus the square root of b squared, so that's -4 squared, minus 4 times a times c. And that's all over 2 times 2. Okay, simplifying this problem here, well, first off, so x is equal to -4. We can go ahead and cancel out those negatives. Remember, double negative rule says that we can do that. Drop down the plus, minus, square root of, and taking care of our exponent, -4 squared. So -4 times -4 is 16, minus 4 times 2 is 8, 8 times 5 is 40. And this is all over 2 times 2, which is 4. Continuing on here, x is equal to, move over the 4, plus or minus the square root of, we need to do subtraction here, 16 minus 40. So remember, if you have $16 in your bank account and you spend 40 bucks, well, hey, you're now -24. And that's all over 4. So I want you to pause here for just a moment and take a look at this problem here. Specifically focusing on this square root of -24. So hopefully you have learned at this point that we actually cannot take the square root of a negative number here. We get, our solution is not a real number. And this is why. So remember what a square root implies. So let me use the square root of 25. Now, the square root of 25 is a plus or minus 5. It can either be a positive 5 because 5 times 5 is 25, or it could be a -5 because -5 times -5 is 25. But Can you think of a number times itself that'll get you a negative anything, a negative 24, a negative, 25? There's really, honestly, there's no possible way that you can get this negative inside here, because a positive times a positive is positive, and then a negative times a negative is also positive. There's no way you can multiply a number to itself to get a negative number. So this is just not possible. We cannot do it. We do not get a real number. So our solution here, not a real number or no real solution. Every book, every teacher states that just a slightly different way, but there is no solution to this problem. We cannot continue on. No solution.